Aloha. So we're going to be solving problem 2 in chapter 4 of the Giancoli physics textbook. And we're given that there's a 68 kilogram astronaut. And we're asked to find his weight. This is the mass of the astronaut. We're asked to find his weight on Earth, on the moon, and on Mars, as well as in outer space traveling at constant velocity. So part A, the weight on Earth. We know that weight is a force. Maybe we're used to thinking about weight as almost just like mass, but mass is an inherent property of an object, and the weight is really a force that depends on the acceleration due to gravity. So I'll label it W, but this is really force of gravity, usually labeled FG in physics textbooks. And this is equal to the mass, just like any force, mass times acceleration, except where the acceleration is g. And on Earth, we know that this is 9.8, approximately 9.8 meters per second squared. So plugging in the mass at the same time, 68 times 9.8, and this will be in newtons, kilograms, meters per second squared. And we can plug that into a calculator and get 666.4 newtons. But remember, we only want to report the number of significant digits that we're using, which is 2 significant digits, 9.8, 68. So this is roughly 670 newtons. So then part B, we're asked to find this for on the moon, where we're given that g is equal to 1.7 meters per second squared. So again, we just use the same formula for weight being mg, and you just are going to plug these numbers into the calculator. Still the 68 kilograms. And now we're not going to use 9.8 meters per second squared. That's the acceleration due to gravity on Earth. We're going to use the 1.7, which they told us, given in the problem, for the acceleration due to gravity on the moon. And then approximating to 2 significant digits, you should get 120 newtons. Part C, we're just going to do the exact same thing. They also tell us the acceleration due to gravity, but on Mars. .7 meters per second squared. Still using the same mass, because this is all about the same astronaut. 68 kilograms. And the answer you should get for that, just plugging into a calculator and approximating, 250 newtons. And then part D is where it gets a bit different, because we're now told that the astronaut is in outer space, not on a planet, not feeling gravity, and he's traveling at constant velocity. And when velocity is constant, that means that acceleration is 0. Draw an arrow. This implies a equals 0. Because remember, the acceleration is just a how the velocity changes in time, but it's constant. That's what we're told in the problem. And then weight is, or force, this is equal to ma, but when a is 0, that means it's equal to 0. So for traveling at constant velocity in outer space, there's just no forces acting on the astronaut. So that's it. Thank you for listening.